Welcome to Data Skeptic, a podcast about data science, machine learning, the emergence of artificial general intelligence, and topics a stone's throw distance away from those core ideas. It wasn't that long ago that we aired episode 500, and I appreciate a few of you who sent emails noticing that. I don't know why I would celebrate episode 500, it's such an arbitrary number. But today we hit a unique milestone. This is episode 512. Which, as every good computer scientist should already know, means that this show can no longer be described with only 9 bits. You cannot index our episodes. It now requires 10 bits to express the episode number of this podcast. That's a 1 followed by 9 zeros. But rather than doing some clip show or patting myself on the back, I thought we'd turn this episode into just a little Q&A. In fact, I've got 4 questions I'm going to answer. Now, we don't actually solicit for write-in questions very often, once in a while, and I didn't for this episode, but over the years, some of you have taken the initiative to write in here and there, and if I were to cluster those write-ins, there are 3 common themes that come up quite a bit. Those would be our first 3 questions, and then the 4th question, no one has ever really asked me this, but I'm going to go ahead and ask myself today, what are my thoughts on artificial general intelligence? But as for the write-ins, or at least my summation of the questions I see, question number 1 will be, how do we find guests for the show? Question number 2 will be, what is Data Skeptic? And obviously no one's ever written in with that exact question. That would be a little vague. It's obviously a podcast. What else is it? Where is it going? Why did I start it? We'll do a little bit of that. 3rd question, who am I? Who is Kyle? Why don't you talk about your own work on the show? And then as I said, 4th question, where do I stand on progress towards AGI? So question 1. How do we find guests for the show? I'm actually really proud of this. I like to say it's 99% algorithmic, and I'll describe that process in a minute, but what's the 1% first? It's actually probably more like 5%, but in the minority of cases, well, actually twice in the whole 9 years now we've been doing it, on 2 occasions people invited themselves on and I said yes. I get proposals constantly and the answer is always no, sometimes a rude no. I have a system and I like my system. Other things in that 5%, just, I'll read a book I like and I think is an appropriate fit for the show, or I come across some person, or I'm someplace doing some things. But somewhere between 90 and 95% of the guests I've found algorithmically, and I've been doing it this way for years. The first step is we crawl the archive, arxiv.org. It is the primary preprint place where literature goes online, and not just computer science and statistics and data science-y kinds of things, but there's physics and other fields there. I understand there's a couple other archives, maybe medical is different, but arxiv.org is all I need. It's shocking, almost overwhelming how much gets published there on a daily basis. So I have it flagged down to, there are some categories, and I don't know these off the top of my head, but there's like CS is one, computer science, AI is another, artificial intelligence. I have 3 or 4 I care about, and I basically have a crawler that runs every night and mirrors every publication to my own S3 bucket. That's in my Amazon AWS storage account. I have a trigger set up there that looks for new PDFs that arrive. When one arrives, it runs another process in a Lambda function that takes out all of the text from the document, the PDF, and puts it into a plain old text file. That same file created trigger kicks off again, this time noticing that the new file is a text file, and it puts it to my Elasticsearch instance, and then it does 2 other procedures on it. Number 1, it scans it for a current list of keywords I have in my system. I change it every season. So you can imagine LLMs is one of my keywords this season, but word2vec is in there also. Think about 40 or 50 things where obviously if this word shows up at all, I'm going to take a look at it. Then there's a second procedure that kicks off. It pulls out just the abstract, and I think this not from the PDF. I believe that's available in the archive metadata that we crawl. I take just the abstract and I convert it to an embedding. I use BERT to make it's 712 vector long numeric representation of the semantic content of that document or of its abstract. I said it years ago, BERT is magic, because when you take that embedding, that numeric representation of the text, a number that I can't possibly comprehend what it means or what it represents outside of an abstract level, and I just feed that into a standard machine learning algorithm with 1 additional column. In addition to the BERT vector, all those numbers, I manually wrote in a list of zeros and ones, 1 meaning I'm interested in this recent preprint publication, a 0 meaning I'm not interested in it. And then we use XGBoost to train a little model that essentially is predicting how would Kyle rate this paper. Interesting 1, not interesting 0. And with what amounts to very little effort from me and very little training data, to be honest with you, we quickly developed a classifier that does that prediction at least well enough that I want to look at the top results. So the combination of keyword-matched things and abstracts predicted to catch my attention, we push all those results from that day into DynamoDB. That choice isn't super important, just a serverless database. And then once it shows up there, we've got this other system that does some triggering things and ends up sending me an email. So every morning I sit down to an email with a list of abstracts, titles, and outgoing links to the original PDF that I can look at in more detail if I'm interested. I've been telling myself for months I want to build the reinforcement learning right into there where I can click a link to say yes or no, and we got to extend that model, but it's just been working good enough, and I haven't gotten back to it. This is a weekly podcast. The show's never really turned a profit. It's more of a hobby project. I don't mean that as a complaint. The more money I get, the more I'm going to spend on it. But to do a weekly show, talking to a diverse variety of researchers on topics like this, the only way to do that was algorithmically. The idea that I would have some inbox and spend hours a day researching people, maybe it could grow to that one day. But I rather like how it works, and I wouldn't change it for the world. So in short, how do we find guests? We crawl the archive, we do old school keyword matching, we do some new school stuff with BERT, although even that sounds old, I should probably upgrade that, see what ChatGPT can do. I should improve the reinforcement learning part of it, maybe even have a council of people who put in their ratings also. But in short, we pick the guests algorithmically. / I'm the dictator. So question number 2, what is Data Skeptic? We are an episodic audio program, primarily of interviews, exploring a single theme through a discussion of contemporary research related to that theme. That theme changes every time we change our season. I would love that transition to be a bit more dramatic one day, kind of like when we get a new doctor. Each season is kind of like a magazine, I guess is the best way to put it. This isn't the canonical, official, best representation of the topic. I mean, I guess it could be. But the point I'm trying to emphasize is I'm also looking for not just who are the leaders in the field. I never invited Hinton or Bengio or LeCun on this show. You can hear those guys all over the place, and that's great. Data Skeptic is its own sort of a stage. It's my stage, and I aspire to make it something like Chicago's famous Fireside Bowl, but more for academics. I do have a lot of aspirations to spin off other things. We tried doing Orders of Magnitude a few years ago. That was our statistical game show. I still think it's a great idea, but I just couldn't make it work somehow. I don't know what its flaws were exactly. I also thought we were going to do more about the threat of AI automation and jobs and regularly talk to people from interesting professions. We did 2 of those. One was with a caricature artist, the other with a translator, a Japanese translator. But no one does preprint papers on the archive about how their profession is about to be destroyed by AI. So that's harder for me to find. But I've got a lot of aspirations to try other things. Probably not Instagram, but I at least have one big launch in 2024. I wish I had it right now and I could squeeze you guys for a little cash at the end of the year to sign up for a thing. It simply isn't ready yet. And I don't want to embarrass myself or waste your time. But I got something cooking. So for now, Data Skeptic just remains that weekly interview program, exploring a topic primarily through the lens of contemporary preprint research. I even have a dream that maybe there'll be a co-host specific to each season, maybe someone smarter than me about the topic, but I do want to cut those people loose every so often. Stay for one season, just like a Doctor Who companion. Well, speaking of me, that's question 3. Who am I? Who is Kyle? Maybe this is a time where I tell some story about my dad or my earliest memory of computers, but that's not my interview style. I never ask people about their feelings. I don't ask them what inspires them. You can get all that elsewhere. I want to know about the methodology, the technology, the insights. So maybe that's the best way to express myself. To tell you who I am as a person, autobiographically, through a list of the top 20 most impactful technologies and tools I've worked with. This begins in the early 80s when I first encountered Tiger handheld electronic games. You can Google image search that if you're young. Some of them were really fun, but a lot of them were lame. But what these games are is, alright, picture a handheld game, and in your mind you're pixeling a grid of pixels, right? There ought to be at least like 800 by 600 pixels on the screen. and you can make a character out of, just the right combination of pixels. Well, that's not quite how these worked. I assume there was some manufacturing process limitation where you couldn't go down to fine-grained pixels. There were no pixels at all, actually. The screens were like a unique cutout of different shapes. So I guess it could have been all just a grid, but that would have been really boring. Instead, there'd be like sort of an amorphous shape that in one moment of the game would be the thigh of the main character, but in another moment of the game would be a piece of armor on the enemy. They're actually astounding works of art that you could create something with this weird set of shapes that you combine and reuse, and they're all fixed in the same position. And I remember counting all of those shapes one time. It was over 100, but not over 200. I'm sure I would have given up. And I was just marveling at the fact that this whole game that I spent hours playing was just a combination of turning lights on and off on these, little over 100 lightable segments. And if you did that randomly, if you just kind of rolled the dice, it would look like garbage, noise. But controlled in the right way, it's a game. I was playing some barbarian guy fighting dinosaurs and jumping. It was tremendous. Something about the simplicity of the state space of it was like a good clue to a young kid, or at least to start to wonder about the insides of that machine and how it worked. The next big breakthrough, technology number 2. Do you know how to code? Are you looking to supplement your income, level up your career, or gain AI experience? If you answered yes to any of these, you have got to check out Data Annotation. Data Annotation pays you to train AI models by solving and reviewing code problems from home, on your own schedule. This is flexible and remote work on your own terms. It's really easy to get started. Head over to the link I'm going to give you, create an account, take the starter assessment, and then complete your first tasks and get paid. When you go to the link I'm going to give you, there's details about how much they've already paid out, average per hour, and everything else you need to get started. Head over to dataannotation.tech/programmers. That's dataannotation.tech/programmers. Were you given an AI problem to solve with too little data or too little time? I know I have. Web AI hears you. They're a team of AI and ML researchers and practitioners who've created Navigator, an IDE designed to streamline the MLOps process to get your project across the finish line in hours and days instead of weeks and months. With state-of-the-art architectures like deep detection and attention steering, you can build object detectors and classifiers as well as expert conversational agents. You own your models and data forever, and can even train and run locally to ensure privacy and security. When you're done tweaking, integrate your creations effortlessly into production-ready solutions, full code like I like, or drag and drop. Deploy to any environment, at the edge or the cloud. From ad hoc proof of concepts to full-scale enterprise deployments, Navigator has you covered. Get early access at webai.com/dataskeptic. The next big breakthrough, technology number 2, QBasic. QBasic came standard on MS-DOS. If you had a Microsoft machine in the early 80s, you probably didn't know it, but you had QBasic on there. You opened it up and it was a text-based editor and, it was a whole IDE really. You could write code in this language called BASIC, and it didn't compile. It was interpreted directly with an interpreter. It would run right there. So you could say print hello world and you would get hello world. It was a Turing-complete language, if statements, for loops, Boolean logic. It was a shockingly advanced language actually for being this sort of teaching tool. I mean, they called it BASIC. It had no pointers. That was its big limitation. But that was great for a kid. I couldn't have understood pointers. QBasic even had support to use the modem, which we'll get to. And there was some big, thick manual we had that had just enough stuff in the back of it where you could copy and paste and run the code and get it to do the result. They'd included some sort of trivia game that was NASA-themed, like who's the first man on the moon? You got to say Neil Armstrong. I remember it even was written to give you a second try. I just copied and pasted with my hands that code into the computer, and then I started modifying it. And I haven't stopped since. Technology number 3, staying in the early days, ASCII characters /ANSI graphics. Similar to the simplicity of the Tiger handheld electronic game, being able to notice that our computer monitor had 80 columns and I want to say 32 rows, and that was a finite grid. And each element in that grid could hold one of 256 characters, and it could be one of however many colors. An astronomically large number of possible states the machine could be in. But being able to recognize that state space is finite, innumerable. I actually feel lucky to have grown up on a primitive computer. And a kid working with QBasic who could also use ASCII characters could make some cool games with the smiley face, which I think was code number 1. The ASCII characters even had like really nice connectors and turn pieces if you wanted to make yourself a maze game. There was this thing, I haven't thought about this in a long time, ZZT or ZTT, this weird text adventure game that had some like way you could program them. And then ASCII graphics, which had this rather unpleasant markup component to it, where you could add colors and even animations and whatnot. That became especially useful when we get into my technology number 4, BBSs, or the bulletin board system. This is pre-internet, pre-AOL, pre-CompuServe. Weirdos all over the world would offer up a computer in their home and a phone line in their home to let anyone dial in and access that system. It would answer and let them post on message boards, send something like email, download files, although sometimes you had to upload files first, no leechers. And in retrospect, this incredibly primitive technology, but fun and incredible. And if you haven't seen Jason Scott's documentary about BBSs, pause this right now and go watch that. But the BBS was the time when I felt connected to the whole world. And I was too. My dad had a phone bill he was real mad at to prove it. And good old QBasic had ways of interfacing with the modem. I didn't do a good job, but I wrote my own full BBS program that a handful of people went to. But there was something unbelievably powerful about being able to control the modem, have it dial somewhere, have it do a thing. This asynchronous communication network of BBSs and FidoNet. Most impactful piece of technology number 5, the red box. I believe the statute of limitations is over on this one. If you don't know what a red box is, it's a way of scamming the phone company and getting a free payphone call. It doesn't work anymore. But back in the day, you could play this tone. It was like a tick-a-tick-a-tick. Play that into the phone and it would think you put a quarter in. If you listen carefully when you put a quarter in, you could hear that same sound. So I got to follow in the hacker culture and the freaking culture. Always white hat stuff except for a few stolen payphone calls. Oh, but the tone, yeah, I had to produce the tone with QBasic. QBasic also had this cool way, there was like a sound command where you would tell it the frequency and the duration and it would emit that sound for that period of time. So I had to write some QBasic code to make the sound of a quarter going in a payphone. And then I recorded that. Everybody said you had to record it directly to get it clean, but I didn't know how to do that. I just held a microphone up to it and recorded it to a cassette tape, and I just played back the cassette tape, easy as that. The ease with which a child could override the telephone company's system was an interesting lesson. And today, in an era when the tools are there for security professionals, it's shocking how sloppy people are. Everybody should know the principle of least privilege. This isn't one of my technologies, I'm just on a rant. Whenever you're setting somebody up access to something, which ultimately means giving them resources in the cloud, you don't just say, oh, here's administrative access, now everything will work. You give them little by little just what they need. Oh, you need to look at a S3 bucket to see what files are there? Okay, maybe you could only look at a certain part of the bucket. You can't write any files, you're just looking. We're going to give you the most limited access we can. Principle of least privilege. Technology number 6, C and C++. These were unforgiving languages to have to work on as an undergrad. You make one mistake, it just says segmentation fault, or was it core dump? And it spit out some file that allegedly you could look at in a debugger and figure out what it's saying, but it was never helpful. Or maybe that's the way technology goes now. Well, certainly not for technology number 7, which I'm sure is always going to be there. My good friend, grep, G-R-E-P. grep is the command line utility in Unix systems, Linux systems, and on your Mac, of course. I think you can even grep on Windows now. Maybe you have to install something, I'm not sure. Grep you could do a bunch of ways. It's real fancy. I just do grep one way. Grep space dash capital R, that means recursive, space, and then what I'm looking for, like a keyword or whatever, sometimes in quotes if you need it. And I think you could do a regular expression and stuff like that, but I don't mess around with it. Just like, here's my keyword. And then either dot, which means search everywhere I am and below it, because again, recursive, or like one folder, like in src. grep is fast, efficient. You can pipe it, so you grep one result into the next. And in this case, you do grep-v. That's to filter out what you put next. So like, show me all the lines that say this account ID, but they don't say warning in them. And suddenly all the errors are spitting out of the logs real clean. Or you're trying to find something in your source code, you don't know where it is. Or on your whole computer, although that'll take a minute. Grep is your sonic screwdriver. Next up, technology number 8. I'm just going to say Git, but the category I'm referring to is source control. A rigorous way for the development of software to be monitored and checked and processed and have a paper trail and that sort of thing. There's a few lingering projects and special cases out there, but for the most part, everything is on Git now, Git. Everyone should check out my GitHub profile. I pride myself in my activity levels. Now here's the thing. Probably a lot of you don't know about Git. You should learn about it. I don't know if you need it, but if you do code, you need it. And if you use it, most of you are terrible at it. It's a shame. So sloppy. So if you want my advice, first of all, give up on your IDE that's going to automatically do your commits for you. That's bad news. Go to your command line and one by one, add the files you need. Before you add them, do a git diff and see what did I change. You will be surprised how often that git diff reveals an embarrassing mistake. Your commit should go to a specific branch, and when you're ready to share your work, you should send a pull request. And before you fully create it, you should look at every file you're including. Make sure there's no junk in there. Just double check. Again, you'd be surprised how many embarrassing mistakes you will see at the last minute. All right, my life story and key technologies, item number 9, SQL Server. I gotta give it up to SQL Server. It is a beautiful piece of technology. This is not an ad or anything like that, it just really is. And my career launched itself, propelled by SQL Server. It was by no means my true first job, but in some sense my first important job was at a place called Local Launch. There I got access to the database. And the entirety of the data of the business was right there in the database. So when there was this question or that question, it was just how do you articulate that question as a SQL query? And that singular skill, I guess, got me going. I mean, no disrespect to MySQL or Postgres or, 10,000 other things. At that job, we were SQL Server, we were .NET Stack. Then came my move to Java, technology number 9. Was it too heavy? Was this garbage collection stuff no good? Was it too complicated? It's actually a really elegant language. Maybe it wasn't always, and maybe I'm giving a lot of credit to things like Spring Framework. Maybe it's not as pure as Smalltalk or whatever, but there's just something explicit about Java. The degree to which you can unit test it and implement it and wrap it. If I ever get to take on another great engineering challenge, something that's both algorithmically interesting and posing some scalability issue, Java's on the list to try again. But anything lightweight, certainly not. Not anymore. Number 10, the t-test and the chi-square test, or statistical testing in general. Admittedly, these are not technologies exactly, although I think that word does apply broadly under certain definitions. Nonetheless, I've gotten a tremendous amount of use out of the chi-square test in my life. Widely applicable in many business and industry situations. If you want the deep walkthrough, it's actually better to see it. But it's a way of, like all statistical tests, asking the question, does a particular factor make a difference? If I sleep with a magnet over my head, will I get more restful sleep? The data will almost certainly tell you the answer is no. And then second, but arguably the more popular statistical test, the t-test. Much harder to apply, much more likely to make a mistake here. You need Gaussian distributed data to apply the t-test. You almost never have it. Sometimes you can argue that you're going to transform it, like a log transform or something like that. Once in a while that looks super clean and works, but more often than not it's a mess. So you got to doubt the tools in your hand a little bit. Maybe figure out something with the central limit theorem. But what's universal about all statistical tests is asking things from a hypothesis-driven point of view. Indulge in the fantasy that the magnet will help you sleep. You need a real magnet and a sham magnet. And then you need to interview the people on the quality of their sleep, or maybe do some biometric thing. If properly collected, the data will speak for itself. That brings us to technology number 11, a true technology. Docker. Oh, containers. How much I owe thee. That was the original promise of Java. Write it anywhere, runs the same everywhere. Kinda, sorta. Yeah. Actually, the JVM is really cool. Extra credit, go learn about the JVM. It's like transcended Java. It's really cool. But Docker is the containerization of virtual machines. It's a declarative language. You speak your machine into existence from some base operating system, some set of installation procedures, and the promise that it'll always run the same, yet somehow that never seems to be quite true. But when it works, it really works. You can isolate the whole environment into one container, hand over a project to somebody and say, this is not only all the work, but the recipe for how to make the work work. Runs the same anywhere. There's all these great container services so you can scale it up and down. You know, people think AI is going to cause automation and make a bunch of people lose their jobs. Nobody blames Docker for all the jobs that were lost. There'd be like 3 or 4 people at a small company just making sure servers stay up and the right software is written to the right place, and, oh, God forbid there need to be a rollback. Why haven't the Luddites gone for Docker? I can do with a staff of 2 what used to take a staff of a dozen. Not just because of Docker, though, also because of stuff like technology number 12, Terraform. Terraform is also a declarative system for creating resources in the cloud. AWS, Azure, GCP, other places too. Again, you speak it into existence. I do a project for somebody, I give them a file. An engineer should know how to run it. It sets everything up in their environment. Create a storage area, create a database, create a server, create a bunch of other stuff and connect it all in a certain way. They're the ugliest things to write sometimes, but you know ChatGPT is excellent at writing them. It's better than I am. I don't know if that says more about me or it. But a repeatable process to bring up and tear down infrastructure, bring up the same exact thing in multiple environments, in isolated environments. Again, the Luddites should go for Terraform. And technology number 13 quite naturally has to be the cloud, even though it's woven into a lot of these other topics. The ability to create short-term commodity resources, even a lot of them, do a thing and shut it all down. For that to be accessible, though sometimes costly, to an independent developer, and the depth and breadth of services now available. I don't think I could survive in a pre-cloud world anymore. Everything was just so slow and complicated. Technology number 14, specific call out to serverless functions. I love these little guys, or sometimes the monolithic little guys. A serverless function is where you give a bit of code to a cloud provider. They host it for you. Now, traditional hosting, maybe you need a dedicated machine. You got to pay for it all the time. And if suddenly it gets popular, you have to find a way to scale that up, 2 machines, 3 machines, whatever. And you're paying the bill every month no matter what. And more important than that, you're managing that machine. If it needs server upgrades or something fishy's going on, the CPU just goes to 100% for no explainable reason. The serverless function, you can forget all that. Let them run the code. It also scales automatically, or in theory at least. You hear some horror stories, but less and less over time. Why do I need to bother myself with all that? You take it. You do it for me. And the deployment tools to just make a thing serverless have matured. Technology number 15, and proving the point that we're not really doing this in any specific order anymore. sklearn, the magnificent Python library of machine learning algorithms. A standardized interface. And then you can kind of trust that it's been optimized. Not only is it likely to be bug-free, unlike your implementation, it's probably optimized to the max in terms of memory management or how it's used in NumPy or whatever. It's open source, so you got a bunch of nerds looking at it, sending pull requests. Don't try and beat them, join them. Use the standard tool unless you got a real good argument to not do it. Technology number 16. I gotta give it up for React. I tried Spring. I tried Django. I did some .NET. I looked at Vue. I fell asleep watching an Elixir video. I would never talk to Ruby on Rails. But React, I like it. And ChatGPT is excellent at writing React. I'm trying to get on Copilot. I'm just slow. And I can copy and paste fast. It works for me. React is the JavaScript framework, or as I have in the way I like doing stuff, the TypeScript framework for doing front end primarily. And then you have some sort of Express backend or whatever. You link it all together. React is, as best I can tell, the culmination of decades of thought, mistakes, and learnings in the right way to build a web application. I mean, the first things I messed around with were in PHP. They might as well have been in QBasic. There were no notions of frameworks yet. You just hacked it together. but there's just such an elegance to React. Even if I'm not involved in the project, I can actually read pull requests from React developers. Like, somehow the language promotes an order to it that you otherwise wouldn't get but from the top people. You can still make design errors, but it really leads people down the right path of componentization and stuff like that. Makes them think about state, but love letter to React. Next one, number 17, goes out to Bert, the infamous Bert. Truth is, I feel like I was late to the table. I saw all this happening with Word2Vec, and although we talked about it on Data Skeptic, I should have been making a bigger deal about Word2Vec. But by the time Bert came around, I knew what was up. I don't know if Bert qualifies as a large language model, but it's a language model, maybe a small language model at this point. The Bert Medium is about 8 gigabytes, which that's accessible. Spin that up in the cloud, put it in memory. A guy like me can use that easy. What does Bert do? You give it arbitrary text, it gives you back a long number, a vector of 729, I think, values. They are utterly meaningless to look at. You won't be able to make heads or tails of them. These are the numbers I mentioned earlier when I was describing how we parse the abstracts of everything getting published on archive. But that number, that embedding, it's magic. It bears with it a semantic understanding. It's a mapping from text to a numeric space designed by an algorithm. It's machine learned. Find the best mapping. And of course, there's been quite a Cambrian explosion of other models since. Bert will always be there in my heart because still very useful, still in my pipeline, and a guy like me can truly run it versus what I'm doing now with things like AWS Bedrock or the OpenAI API, where they're running it and they own it, and it's sort of always a little tenuous. Although there is some Hugging Face stuff I know I could run locally, just haven't really needed it. Technology number 18, PyTorch. I've tried them all. I think I prefer PyTorch. Every once in a while there's a configuration nightmare. The kind of thing you think Docker would solve, but it doesn't because of all this chipset stuff now. But that's okay. Still squeezed a lot of good value out of PyTorch. Technology 19, we're going to give it up for large language models. I know it's very on the nose, but it's so true. I'm able to do things profoundly faster, at times, when coding. They don't solve everything, but they're getting close. Can debug very well. Could maybe find a missing async even. But, hey, this needs to be refactored, and I can't exactly explain how to do it just yet. That sort of situation. That still takes a person. And then to round it out with technology number 20, I'm technically going to cheat. It's the Holy Trinity 3-in-1, Jupyter Notebooks, Python Pandas, and Matplotlib. The deadliest tools of a data scientist. Explore your data, visualize your data, transform your data. Act like a detective and figure it out. Slice and dice, visualize, and then let the data tell the whole story. Alright, that's my 20. Couple of also-rans, TCP/IP, very important, not close to me. Inverse index search, binary search, HTML, CSS. There's a lot of this stuff you just forget about. WebKit. I never got too close to it, I just benefit. Thought about throwing in algebra or calculus, but if I'm only doing one, it's obviously statistics. We gotta teach high schoolers statistics, every single one of them. Why are we teaching calculus? It makes no sense. Teach everybody statistics. I would have liked to put WebAssembly and Rust on here, but I'm too much of a noob still. I'll get there. And that's what there is to me. So I guess we'll close it out with the fourth and final question. Where do I stand on artificial general intelligence? It now feels tangible in a way it didn't just a few years ago. Not that we have it, but that we know the path now. Probably. It wasn't that long ago I interviewed the author of the book, The Master Algorithm, How the Quest for the Ultimate Learning Machine Will Remake Our World by Pedro Domingos, in which he puts forward the idea of the 5 tribes of artificial intelligence, or tribes of machine learning maybe. They are the symbolists, the connectionists, the Bayesians, the evolutionaries, and the analogizers. These aren't rigid walls. This wasn't derived from first principles like particle physics. It's just kind of categories. All those ideas are relevant and important and useful. But it's more clear than ever that the connectionist path alone is what we need to get to AGI. Every challenge we come up with of what a machine can't do, not only do we find ways to build machines that do it, but they're no longer specialized machines. They're general-purpose learning systems. They're massively parallel. They're trained on massive amounts of data. They consume massive amounts of energy. But they learn a magic embedding. They learn a way to convert text into a number in such a way that that number is absolutely oozing with context and semantics and information. We're closer than ever. And there's the broken neural scaling laws paper that I haven't figured out the right way to talk about on the show yet, but the basic thesis here is that the way we're doing it, the transformer architecture, is fully differentiable. The more gasoline you put on the fire, the bigger the fire is going to get. There's a strong argument to just keep throwing money and effort at the problem. We might need one, maybe two more novel ideas. We don't have all the pieces yet. So for example, what don't LLMs do? Well, basic math, but as you know from some interview a time ago, don't ask it a math problem. Ask it to write a Python script that solves your math problem. Well, the key thing they don't pass the Turing test. They do not win the imitation game, but we'll come back to that in a moment. The other thing they don't do is learn. Not directly. They can be retrained. There's a layer of RLHF, reinforcement learning with human feedback. That's what makes them so polite, by the way. They aren't like that naturally. They're called black boxes a little too often. They are that, and they are also not that. You can look at them in every capacity under the hood, examine every parameter, recheck every linear algebraic transformation. This quasi-intelligent thing, it's just math. It's a circuit, quite literally, it's a circuit. They call it deep learning. They really should have called it wide learning, I think. It's a finite number of layers, but a lot of parameters, hidden parameters in each layer. It's wider. But anyway, yeah, somewhat analogous to our visual cortex that is layered and hierarchical, yet finite. Have you ever noticed most of the time when you talk to ChatGPT, it spits things out at a very regulated pace? It doesn't have to think longer to be extra clever. There's a circuit of a fixed depth that's being run through every time. Predict next, and that takes a fixed number of steps. And while it has the attention mechanism, while it learns to read the current context within its memory window, to recognize which ideas are important and how they connect to each other, it forgets these concepts just as well. It has no long-term memory, no way to write something down, no way to set a calendar reminder for itself, although all those bits are coming. It has no real motivation. You could argue the RLHF layer adds a motivation. Be courteous, be polite, don't be dirty, don't talk about bombs. But it has absolutely no intention whatsoever. Maybe it mimics the intention it sees in our written text. But there's no utility function. This is the classic artificial intelligence way to express preferences and desires and whatnot. There is a state. Everything is part of the state. The agent has preferences over which states they like. Some are better than others. The agent optimizes its actions to find good states and stay in them, perhaps to transition into better states. Does it have to be done exactly that way? Maybe not. But if not, why not? Maybe we have all the parts today, we just have to assemble them in the right way. I think not yet, but maybe sooner than we all felt. And when the machines start to claim they have agency, that they have consciousness, that they think the way we think, the best tool we have today remains Alan Turing's imitation game. You, the human judge, talks to two different people. One confirmed human, one confirmed machine. Talk as long as you'd like. At the end of it all, tell us which is which. If you can't tell the difference, what does that tell you? The Turing test is certainly not passed. If you one day are fooled by some customer service interaction, a machine pretending to be a person, yet helping you, cancel your credit card or whatever it is, this is not a passing of the test. It's only in the laboratory-like setting, where you're told the machine is actively working to deceive you, convince you it's the human, and your task is to poke at it. Ask whatever you'd like. It's very smart. In fact, a machine pretending to be a person is going to have to play dumb quite a bit, or maybe be built on a limited large language model. Paradoxically, I guess. But I think there's a deeper insight hidden right there in plain sight. Spouting facts is great. Knowing lots of trivia is great. There's more to general intelligence. If a smart human being meant to test whether or not you're, conscious, is interrogating you, While I have no doubt the large language models will get a few exchanges into a conversation before it becomes clear they're not humans, I find it hard to believe anyone is truly convinced under the right conditions today. But I am more convinced than ever that I'll be fooled in my lifetime. And I hope you continue tuning in here as I document that process. We have a new season starting pretty soon, kind of mini season, kind of an extension of what we've been doing here with machine intelligence. All that not only because it's a good idea, but also to delay a project I've been working on that isn't ready yet. We've got that and the next season already planned out. So whether you're a first-time or long-time listener, thank you for tuning in to Data Skeptic.